Lesson 4.5 is on scatter plots and lines of fit. So, you will learn to investigate relationships between quantities by using points on a scatter plot and using lines of fit to make and evaluate predictions. Vocabulary: bivariate data, scatter plot, line of fit, linear interpolation. That's it. Okay, so to start off, we want to look at scatter plots and see what kind of relationship or correlation there is between the points. So the first part here, this is a positive correlation, because if you were to draw a line that kind of goes like with the direction the dots are going from left to right, it's increasing, which is like a positive slope. The next one is a negative correlation, and if you can't seem to see a pattern at all, that would be no correlation. So the graph shows the average number of students per computer in Maria's school. Determine whether the graph shows a positive correlation, a negative correlation, or no correlation. If there is a positive or negative correlation, describe its meaning in the situation. Okay, so we're talking about computer sharing here at this school. So if we were to look at this data, does it look like it's increasing or decreasing? As you move from left to right, it is decreasing. So this is a negative correlation. Can't spell. Okay, and then we want to describe its meaning. So if this is students per computer, and this is the year, as time progressed, there were more computers and less were shared. Okay, so a key concept, using a linear function to model data. So if we have a bunch of data, so like looking at this, we have all of these plots, these dots here that are telling us something. We want to come up with, we want to be able to interpret that and use it for making predictions and just moving forward. So in order to do that, the first thing you're going to do is make a scatter plot. So like they did there, and then determine if there's any relationship. If there's no relationship, you kind of just stop. But if there is a relationship, step 2 is draw a line that seems to pass close to most of the data points. Once you have a line, pick 2 points that are on the line, and then write an equation through those 2 points. And then step 4, you can use that line, the equation of that line, to make predictions. So the table shows the world population growing at a rapid rate. Identify the independent and dependent variables. Make a scatter plot and determine what relationship, if any, exists in the data. Okay, so if we're talking about year and populations, time is almost always independent. So we're going to make this X and population Y. So the independent variable always goes on the X-axis, dependent always on the Y. So the population depends on what year you're looking at. All right, so you make a scatter plot, so you make a table and you fill in those points. I just left it here already because if I were to try and do it on my own, it would be a mess and you guys would just get confused. So here it is. All right, once you have a scatter plot, I'm hoping you all know how to plot those points. But once you have a scatter plot, you want to determine the relationship. So if you look at the points, as you move from left to right, they're basically increasing. So that means that it has a positive relationship or correlation. Okay, and then you want to come up with some way to describe it a little bit better. So what we do is we make a line of fit. So a line of fit, you draw a line that kind of goes through the points, the middle of the points. You have the same number above and below, and it tries to come as close as it can to all of them. So this is the line I drew. from this, you want to determine the equation of this line that can describe the data. So to write the equation of a line, you can use 2 points on the line. So I'm just going to pick 2 points on the line. So this here is a point, and then we're going to pick one more. So point 1, that point is, looks like 1800, comma 1000. And let's see, we can pick, let's do this right here. So let's say that that point there is 2000, and it's slightly above 400. So we'll do 4,000. We'll do 4,050, whatever. Okay, so from those 2 points, you're going to write an equation of a line. So y2 minus y1, first thing we need to do is find the slope. So we're doing 4,050 minus 1,000 over 2,000 minus 800, or 1,800. So when I do this, I get 3,050 over 200. So 3050 divided by 200. This is 15.25. So this is my slope. Once I have a slope, I need to come up with the y-intercept. So to do that, I'm using y equals mx plus b, and I'm plugging in the m and one of my points. So I'm going to do this point here. So I'm putting in 4050 for y, 15.25 for x, and 2000, and I'm solving for b. So 2,000 times 15.25 is 30,500 plus b, and that's equal to 4050. So I subtract 30,500 from each side, and I get 26,450 is my b. So that means my equation is y equals 15.25x minus 26.26450. Okay, so once I have the equation, I can use that for later. Okay, so the next part, they must have drawn a line slightly different. So when they did it, they came up with this. They probably drew a line a little bit steeper, which would make that intercept much lower and the slope bigger. But we can use their equation just for the sake of all being uniform. But like I said, on a test, everybody's might look a little bit different. So once you have an equation, we'll use the one they came up with. We could use that to predict the population in the year 20,025. So to do that, I'm putting in 20,025 in for x. So I'm just going to say y equals 35.1 times 2025 minus 63,870. So 35.1 times 2025 is 71077.5 minus 63,870. So when I do that, minus 63,870, I get 7,207.5. So if I'm looking at this in the year 2025, so that'd be somewhere, maybe in here, they're expecting about 7,000. And it makes sense. So we're okay. And that's using, that is called extrapolation. So if you're going outside of the data you have, it's extrapolation. And if it's inside the data you have, so like if I wanted to know the population in 1925 falls within the range I'm in. So that's interpolation. But 2025, that's extrapolation because it's outside of the range. Anyway, okay, so you guys can check your work or try and do some practice problems.